Okay, we're on the CBEST practice exam for mathematics, and this is question number 20. And this question is a fraction question, and a lot of folks get really nervous when it comes to fraction questions because they've forgotten how to do them. It's been quite a little while since they've had to calculate fractions, and they can get a little bit nervous about it. So what I want to do with this question is we're going to work through it slowly and just kind of get you to remember what you did so many years ago to deal with these fractions. The most important thing about fractions is that when you add and subtract fractions, we need to make sure that the denominators are equivalent. So we'll make sure that that happens, and I'll show you how to do that in just a minute. But before we go that far, let's go ahead and let's read the question. Last week Mario walked 7 3/4 miles. This week he walked 15 5/6 miles. What is the difference between the distance he walked last week and the distance he walked, between the distance he walked this week and the distance he walked last week? Well, if we didn't have these pesky little fractions here, it'd be quite easy. We'd take 15 minus 7 and we get 8, right? Well, that's fine, but we have fractions to deal with. So let's go ahead and write the problem as we know it needs to be written ultimately, right? So if we have 15 5/6 minus 7 3/4. Okay, we're ultimately going to need to find that. Now, unfortunately, we can't do this subtraction problem until we get these denominators the same. Well, how do we get those pesky little denominators to be the same? We find common multiples, okay? One of the ways we could always find a common multiple is to multiply the denominators by each other. So in this case it would be 6 times 4 would be 24. So if I put 24 here, I could put 24 here, and that would be fine, except that number can get really big, especially if you're trying to add a number of fractions. In this case it's only 2, but we are looking for the smallest denominator we can work with. It just makes life a whole lot easier at the end. So the way I suggest to do it is to take your largest denominator, multiply it by 2. Okay, start off by 2, and then if that doesn't work, start off by 3, and so forth. So if we did 6 times 2, that's 12. Can we multiply anything by 4 to get 12? Well, it turns out yes, we can. So if I went too fast, what I'm saying is to start off with the largest denominator in your problem, start off by multiplying by 2. 6 times 2 is 12. Okay, now I'm going to write this down so you can visualize it, but you'll do that in your head. And then look at the next denominator. Can I multiply anything by 4 to equal 12 evenly? And the answer is indeed yes. So we know our best solution on this would be to go to 12. So we have 4 times 3, right, gives us 12, and 6 times 2 gives us 12. Okay, so if I do something to the denominator, I have to do it to the numerator. So I'm going to multiply this by 2, multiply this by 3. So 5 times 2 is 10, 3 times 3 is 9, right? Now I can subtract this problem. I've got 10 minus 9, it gives me 1/12 left over, right? 15 minus 7 gives me 8 1/12. So the answer is 8 1/12. Now, just in case you have a problem, I mean, that's the answer for this question. But what I want to do is just take a quick moment, just in case this was like a little bit fast and you're thinking, God, that's great for this problem, but man, I'm not sure I understand how you got that numerator. So if you understand how you get numerators, you can quit the video right here, because all I'm going to do is just kind of do another refresher on how to get these denominators to be the same. So if you don't need that, then you can just go ahead and skip through this part. Let's look at just pretend we don't have this problem. Now we're just going to work with denominators here, and how to get denominators the same. So let's say we're dealing with, oh, I don't know, 3/4. We're dealing with, let's see, let's add, well, let's add 1/16. Okay, 1/16. All right, how do I get these the same? Now you may be looking at it and saying, okay, yeah, I know this 4 is divisible, but let's do it step by step. Okay, here we go. Let's do it step by step. If I take the largest denominator, multiply it by 2, I would get 32, right? Is there anything I can multiply the 4 by to get 32? Well, yes, there is. I can multiply 4 times 8 and get 32. So I know that I can use 32. Okay? So that's why it's so convenient. Now don't forget, anything you multiply down at the bottom, you need to do at the top. So anything you multiply at the bottom, you need to do at the top. 8 times 3 is 24. 2 times 1 is 2. And then, you get 26 over 32. And then that can be reduced, but that's another problem later. Okay? Let me just erase that. Get a little bit bigger. There we go. Let me just erase this here for you. Okay. And go back here. Let's try one more. How about 3 over 12 plus let's do 1 over 9. Now this one's not quite as easy, is it? If I start off with this and I take the 9, I'm sorry, take the 12, that's my largest denominator. Multiply it by 2. Here's draw my lines as I need to make these the same now, remember? If I multiply this by 2, I get 24. 9 times, I can't multiply anything by 9 to get 24. So what about 3? 12 times 3 is 36, right? Can I multiply anything by 9 to get 36? Turns out I can multiply 4, so I get 36, right? And here I have 36. If I do anything to the bottom, I do the same thing to the top. So that's 4. I multiplied the bottom by 3 to get 36. I have to multiply the top by 3, and I'll get 9. 9 plus 4 is 13/36. Okay? And that's how you add and subtract fractions.